We've talked about approximating hypergeometric random variables by binomial random variables and approximating binomial random variables by normal random variables. Let's put those two ideas together to approximate a hypergeometric random variable by a normal random variable. So, for example, suppose there are 5 million fish in a lake, and 1 million of them are trout. I don't know very much about fish, so pardon me if this is not realistic. Let's say we catch 1,000 fish. And let's let x be the number of trout. And let's find the probability that x is greater than or equal to 180. So 1/5 of the fish in this lake are trout, so I guess we'd expect 200 fish to be trout. So we'd probably be pretty optimistic about the number of trout in our catch being greater than or equal to 180. Now technically this is a hypergeometric experiment. I mean, the first fish could be a binomial experiment. Probability of 1/5 is the probability that the first fish is going to be a trout. So if xi is the ith fish caught, the probability x1 is trout is 1 million over 5 million, which is 1/5. But the probability that the second fish is trout, say given that the first fish is trout, is really, well, there's not 1 million trout anymore. Now there's only 999,999, and there's not 5 million fish in the lake anymore. Now there's only 4,999,999. But that is very, very close to 1/5. So let's pretend we are sampling with replacement. Because the numbers of fish in the lake are so much greater than the number that we're catching. We can just approximate that the probability of getting a trout is 1/5 every time, no matter how many trout we've caught so far. So x is technically hypergeometric, but let's define x prime, which is a binomial experiment with 1,000 trials and a probability of 1/5 of a success. So x is approximately this binomial random variable x prime. And then x prime is approximately a normal random variable with mean 1/5 of 1,000, which is 200, and variance 1/5 times 4/5 times 1,000. So I guess 4/5 of 200, which is 150. Sorry, that's 3/4. A fifth of 200 is, fifth of 100 is 20. So a fifth of 200 is 40. 4/5 of 200 is 160. Alright, now we want the probability that x is greater than or equal to 180, which is the probability that y, a normal approximation, is greater than or equal to 179.5, lengthening this interval by 0.5 on the left side. let's let z be y minus 200 over square root of 160. So that we can look this up in a table. Y minus 200 over square root of 160 is 12.65. So the probability that y is at least 179.5 is the probability that y minus 200 over 12.65 is greater than 179.5 minus 200 over 12.65. And this is, let's see, that's 0.5 less than 180. So 20 minus 20.5 over 12.65. And that equals minus 1.62. Approximately. So I want the probability that z is greater than or equal to minus 1.62. So that's the probability that z is less than or equal to 1.62 by symmetry. So if we look this up in the table, we get 0.9474. So in this case, it's very, very likely, given our mean of 200, that we would get at least 180 trout in our catch of 1,000. The end.